Okay. And all right. Well, I've really been enjoying seeing some of your posts on the portal and getting to know you a little better through your introductions. If you haven't done it yet, that's fine. Don't feel like a slacker. Everybody can do it when they get to it. I had someone apologize in the last webinar saying, "Oh, I feel like such a slacker," but there's no. We know that you all have a lot going on, and when you get to it, we'd love to see your introductions. Other people have been able to get through a little bit of the checklist, and I know many of you have been requesting images. Some of you have even been able to process them and post them. And we're going to take a look at a couple of those right now. Here's some of the introductions. I've really enjoyed seeing those, and also people have been practicing their skills posting images that represent astronomy or the sky to them, and it's nice to see those as well. You can see Natasha here in the bottom right actually posted one of her own. She was so excited she wanted to share it right in the Introduce You forum. Some of you have also started using the wiki tool that we put in the educators portal, and there will be wikis for your students in the youth activity portal as well. And this is one way that students can create their own web pages that reflect on what they've learned through doing their astrophotography and their astronomy projects. Here's some of the images people have posted to the wiki. Erica has recently created a video tutorial on how to create a wiki page, and so that's pretty useful, and you'll find it right on the header page for the share your processed.
I got it.
Wiki. Good. Elizabeth, welcome. So I really love this selection of images. We have Diane has a great image of the Whirlpool galaxy, and a couple of nice images of the moon from Lori and Brian, who thinks it might look like a dying star, and then he says, "Or is it?" And I love his sense of humor. And he's got this inverted image of the Andromeda galaxy, which apparently to Brian looks a bit like something you might find in a petri dish. And so there's a lot of fun images to share as well. Now, what you guys are doing as you're using the false color tables to enhance your images is something that scientists here at the CFA do all the time. And I wanted to actually show you a video of Joe DePasquale, who is the science imager from the Chandra X-ray satellite telescope. I think I introduced him in the last webinar. He's going to be one of our STEM mentors. We're actually recruiting a cohort of scientists and grad students and engineers who will also be able to check in on your classrooms and be available as expert commenters on student work. But anyway, I wanted to show you this video that was made of Joe kind of explaining what he does, which is very similar to what you guys are doing as you learn about the telescopes, and similar to what your students will be doing. So let me play that, and I think you should be able to hear it as I do play it.
I work for the Smithsonian Astrophysical Observatory. It's one of the largest astronomical institutions in the world,
Anyone who takes data and turns it into an image of the sky is an astrophotographer. They don't even have to have their own telescope, but they just take data of the sky, wavelengths that you can't even see with your eyes, and convert it into an image. The way that I go about making images is basically go into the Chandra Data Archive and pull out data, and often combine it with data from other telescopes. We're taking something that you can't see with your eyes and translating it into something that you can see, using color as the main tool to do the translation. The real goal of these images is to convey the science behind the image. There's always a press release that goes out with them that explains what you're looking at. And our main goal is to make sure that that information is clear in the image. You can look at it and get the gist of it. The images really tell the story of what's going on in space. As an astrophotographer, I'm not trying to get my own viewpoint out there, but I am trying to help this organization to inspire people through science using these images. And so my decisions as an artist in this process, they are informed by art, color theory, and composition. I use that information to make decisions that then help me to best convey the science and to really inspire people to wonder about the universe, what is up there. It just opens a whole new dimension to space. I know when I was growing up, the images from Hubble were so inspiring to me. In particular, I remember the Pillars of Creation image, the Eagle Nebula. Images like that at that time, I really did not understand how they were made. You know, you look up at night, you don't see anything like that. And you can talk to a scientist about this. They can explain to you that while it's very dim, your eyes can't really integrate light the way a telescope can. But still, there's like a disconnect between when you look up and what you see in these images. I try to keep that in mind when I'm working, that there are people who don't really understand what this means when you look at an image like this, that it's really there. It's not just made up. It's not a false image. It's data that's there. These are physical processes in the universe, and they're beautiful. There's so much beauty in this kind of science that it's almost overwhelming.
So I really kind of like that video of Joe, and Joe will be hopefully featured in a webinar at some time that you and your students can attend and ask questions of him, especially once your students really do understand the same processes Joe was talking about. I really like the fact that he talks about how he is integrating art and science in composing his images and processing the images, and that you have to understand things like color theory to do your best job with the images. And that's really what we're going to do today. We're going to spend some time doing some activities around light and color and colored filters, and understanding how filters transmit and blocks different colors. But before we get to the light and color activity, I want to just remind you that, again, the image processing tool, the JS9 tool, is really just assigning different colors, either shades of gray or different colors in those watermelon color tables or the rainbow color tables, assigning different colors to different pixel values which are in the image. And so I wanted to talk just a little bit more about that, because in a little bit later we're going to be enhancing some of my images of the Orion Nebula, which is what we have here. And I wanted to get into a little more detail before we talk about color, about what you're doing when you maneuver these low brightness limit and high brightness limit sliders. So the image on the left is an image of the Orion Nebula, the raw data image. And when it opens in JS9, you can see that it doesn't look like much. You can't see much of the information that's in there. And one of the reasons is that you need to adjust these sliders to be able to display more of the information that's in that image. And in fact, if I show you this graph, which really tries to convey what's happening when you change these sliders, the image on the left is taking the 256 levels of gray that a computer has to create a black and white image, and then on the x-axis are the 4,096 levels of brightness that the telescope detector can actually measure. So the telescope can measure a lot more information than a computer screen can display at any one time. So what you have to do is choose, by using these sliders, where the important information is, at which values between 0 and 4,096. So in this Orion Nebula image, the brightest stars here are at 4,000 or 3,000, but most of the stuff in the image is very low. And so on the right side, I've pulled those the high brightness limit down to 512. You can see there, to 512. And the low brightness limit up to 250. And so the right image, this is where we're getting much more of the pixels that have information about the Orion Nebula all fall between 250 and 512. And so that's why this is a better enhanced image. Now, many of you also may have been learning the log scale trick, and that's an important thing for dim images. Excuse me. And just to show you that, this is the same Orion image as this one, okay? The same Orion image, but I've used this up here under the scale menu bar, excuse me, a log scaling tool. And what log scaling does is something like this graph. So instead of spreading all the 4,096 levels of brightness that the telescope can detect linearly from 0 to 255 or 1 to 256, it gives more attention to the dim brightness values, and only a few levels of white to the very brightest values, which is, so this image on the left is this red line where I've set the low value to 287 and the high value, so anything brighter than 1700 ends up being white. And that's how you bring that out. And we'll do that live when we get to make a 3-color image later on. I just wanted to emphasize again, there is a lot of math in image processing, and the more you understand that, the more details you'll be able to bring out in your images. Okay, so today we're going to find out how, even though the telescope detector only detects light and dark, so the little CCD detector, all the little pixels, depending on how many photons of light hit them, they either create a large number in the computer file for that pixel or a small number if it's very dim. And so even though the detector can't see in color, we can figure out what color objects in the sky really are by using the red, green, and blue filters. And these 3 images of the Orion Nebula that you see on the screen here were taken through the red, green, and blue filters of the telescope. So that's that setting when you when you request an image where you're specifying whether you want a clear filter or no filter at all, or one of the colored filters. And so by taking 3 different images, one taken through a green, one taken through a red, one taken through a blue filter, and then using software to layer and composite those red, green, and blue images, you can create a true color, or an image, a RGB image that represents the colors you would actually see if you could fly out in space and you had eyeballs that were as big as 3-meter pupils, as big as the big telescope, so you could let in a lot of light. The Orion Nebula actually is glowing kind of pink, and then some colors of green in there. Hydrogen glows with a lot of red color, and so big clouds of gas and dust in the sky often have quite a bit of pink in them. So we're going to do this, and I'm going to show you how to do it yourself in just a moment. But before we do that, I want to do some hands-on activities, and we're going to be a little interactive here with filters. So I'm going to stop sharing the my screen, and I'm going to ask those of you who might have your video camera on right now, if you can mute your video camera, because I'm going to make my video big, and it will help the throughput so we don't tax anybody's wireless too much here. So if you happen to have video camera online, but so I'm going to stop sharing. And here's what I want you to do, is to click on the image of me, and a little pop-up window will pop up, and I want you to click on pin video, the word pin video, and then I will appear in the big part of your Zoom webinar screen. So you want to click on the image of me, and then when you see that little window, click on pin video, and that will pin the video of me to be the biggest one on your screen. Okay. And you'll see my messy office behind me. Try not to pay attention to that, but you'll. I'm going to do some activities with you using some different colored filters, and I have some red, green, and blue filters here. These are actually theatrical gels. There are here in Boston, we have a couple of stores that serve all the theaters, and one of the things you can buy at those stores, besides makeup and costumes, is lighting gels, and these end up being very good for doing lots of activities. Sometimes a theatrical store will donate them, a few sheets of filters for educational causes. There's also some places online to order some sheets of filters, and we have that information in our activity write-ups. RainbowSymphonyStore.com is one such place, but we have a couple of other options. So I have little pieces of filter on a little wheel here, and I'm going to use them on my camera here. We have a red and a green and a blue filter. And I'm going to use those to do some activities with you. With students, I often take little pieces of the gels and put them on a bookmark like this. And so in this webinar, I'm going to ask you to predict what's going to happen if I put a red filter over the webcam, but you would ask students, what will they see if they look through the red filter? Okay. Okay, so I have here a little group of stars, star 1, 2, 3, 4, and 5. And you'll see that they're different colored stars. They're not star-shaped because we know stars are actually round, not star-shaped. And so I am going to place the red filter over my webcam so that the light from my office lights that is reflecting off this red star and getting to the camera, so you see red. I mean, the white light is hitting the red star, and all the colors are being absorbed except for red, which is being reflected back to you. This white star is reflecting all different colors to you, blue and so on. I want to have you make a prediction. What's going to happen when I put the red filter over the webcam? Will the red star disappear? What will happen to the other stars? Will any stars turn different colors? If you could type in the chat box any predictions you have or that you think your students might make, but and don't worry if you don't know. We get points for typing anything in the chat box at all. You get points for taking a guess. Oh, so we have two predictions. The red star will be the brightest and the red star might disappear. And this is very typical of what any group of people predicts. Is they, you know, you think something's going to happen with that red star. How about some of the other colors? Any predictions about what might happen to, say, number one, the green star? The 5 will disappear. The blue will turn purple. 2 will turn pink. Green will appear to be black. The white and red stars will be the brightest, and the green and blue stars will turn dark. I think my students will predict the stars will change color. Okay. Only the red star will appear. The yellow will appear very bright. Okay. So we have a range of predictions, and this is very true of most groups of people who would be asked this. And so I'm going to put that red, we'll test our predictions. Okay. I think my filter is getting smudgy. It's out of focus here. Let's see if I can fix that. Okay. So the red star did not disappear. In fact, it's still bright. You notice that everything in the image is now shades of red coming through the red filter, but things are brighter or darker. Things appear bright or dark, and that green star, number 1 here, it disappears. So let's try and make sense of this. Remember that what the red filter does, that's between me and you, is it only lets red light through it to the webcam. So things that are sources of red light will appear bright to you. So the red star is a source of red light. It's reflecting red light from the room back at you. The white star is a source of red light reflecting back at you. Even this yellow star has a little bit of red light that it's reflecting back at you. But the green star is only reflecting green light. And the red filter only lets red light through. So there's no light getting through to you from this green star, and there's very little light getting through to you from this star. Okay, great. But now I'm gonna put the green filter in front of the camera. I'll put the green filter in front of the camera. So now I want some more predictions about what will happen when I put the green filter so that only green light gets through the filter to the webcam to you. Any predictions? Sources of green will appear bright. Okay, yeah, and the sources of green, is this red star a source of green? Green star should be bright as well as the white. So this is the green and the white one. you'll remember here, right? I'll get you back, remind you which these are, green and white. Okay, the prediction is should be bright, and the red should be dark. Okay, here we go to the green filter. Excellent, excellent. Yes, so the green and the white are both sources of quite a bit of green light coming towards the camera, but the red one is not, and so that kind of disappears. All right, excellent. And the yellow has a little bit, and the blue less so. Okay. And likewise, when I put the blue filter, again, the blue filter, neither the red star or the yellow star is reflecting much blue light. So these appear dark. The blue star is reflecting blue light. The white star is reflecting blue light. And the green star, this is actually not so much that the star is reflecting blue light, but that the blue filter is not a perfect blue filter. It actually lets a little green light through too. But now, Pam, yes, exactly. In fact, I have to tell you, I didn't do the numbers in white the first time I put this together, and I did some experimentation, and I realized, this is not going to work. Some of the numbers disappear. So, yeah, that's exactly right. Now, I'm going to go back to green, and I'm going to actually put this down, and I don't know if you guys.
Don't worry.
Okay,
I'm
you are.
sitting so you
You are
can't see
okay. I don't know if you guys remember what Erica and I were each wearing today, but if you can't remember, you might be able to tell just because the green filter is on, and our Erica's dress and my sweater are kind of giveaways as to what color they might be. You had red, Erica green. Yeah. Okay. And so if I want to show you what happens if I go from the green to the red filter. So I'm dark, Erica's dress is light. I'm light, Erica's dress is dark. Through the red filter, because of course red is blocking green from her dress, and it's letting through the red from my sweater. So nice work, everyone. Excellent work. Yeah, so working with the filters in a hands-on way really helps build your understanding of how filters let through certain colors and block other colors, and that's one of the keys that astronomers use to understand what the true color of objects in space is. You'll notice also, actually behind me here, I have these three towers of Lego blocks, and I don't know if people noticed as I was putting the filters, but I'm going to give you one more prediction to make, which is if I put the red filter back on again, how are these three towers that are in front of a white background going to appear? Any predictions? And Pam, colored cellophane, it really depends on the saturation, of the color. Some cellophanes work pretty well, while others don't, and it takes a little bit of experimentation. So you want one that's pretty clear and also saturated red. Okay, I think the green one will be dark, the red will be light, and the blue a little bit. All right, let's check it out. Keep your eye on those blocks. All right, Okay, so the green and the blue, the actual color of the blue of those blocks is blocked quite well by this red filter. It's only letting through the red tower of blocks. You guys have gotten very good. So while your predictions at the beginning were kind of all over the place, you weren't quite sure, you've gotten pretty good at making these predictions. Now, before we go to astronomical images, I want to show you one more example of using familiar things to create a 3-color image, actually using photos of these block towers right here. So it turns out that we're going to have to introduce a new image processing tool to you guys to do 3-color image composites. And that image processing tool is called Pixlr. It's online, it's web-based again, so you don't have to download any software, and it is free. And Erica has some written instructions on how it works, but I'm going to demonstrate it right here, and you'll be able to consult this webinar recording, but we'll also make a short tutorial about it as well. All right, I'm going to, let's see, what am I going to do here? I'm going to share my screen again. Okay, share my screen. Okay, and I'm going to bring the Pixlr website over here. Let's see. Okay, have it in this other tab. So it's at pixlr.com. And so earlier today, Frank took 3 pictures of those 3 towers of blocks using my cell phone, just a regular digital camera, and any digital camera will work for this. So he took one of the pictures of the blocks through the red filter, one through a green filter, and one through the blue filter. So he just used the filters to take those pictures. And I'm going to show you, once you have a picture that's taken through a red, green, and blue filter that are not astronomical images, because Pixlr doesn't work with FITS images like the telescope makes. Once you have a PNG image, a PNG image, or a JPEG from a smartphone, you can use the Pixlr editor, and we're going to use it for the Orion Nebula in just a moment. But right now, we're going to use it to create a 3-color image of those towers of blocks. Now I know a smartphone already takes a color image of blocks, but actually behind the scenes, smartphones are doing just what we're about to do. There's actually little red, green, and blue filters inside the optics of your smart camera. All right. So you want to use the Pixlr editor. And I've already got these 3 images taken through the 3 filters on my computer. So I'm going to open them from the computer. I put them from my smartphone to my desktop. And here they are here. These 3 images, R, G, and B. I'm going to open up the red one first. All right, so there's my image of the 3 towers taken through the red filter. And again, you can see that even if you didn't know the color of the 3-block tower or the 2-block tower, now that you know a little bit about filters, you might be able to guess just because they appear dark in a red filter image. In Pixlr, in order to create layers and then composite them into an RGB image, you need to use the layer tool. So I'm going up to layer. I'm going to open my green image as a layer, as a new layer. So the red is the background. Here's my green image. Okay, there's my green image. Now my green image is on top of the red one. And now I'm going to open a third image on top of that as a new layer. Open images layer. And that's my blue image. Okay. So I have this blue one on top. If I hide that, if I uncheck that over here, you can see down to the next layer, which is the green layer. And if I uncheck that, you can see down to the background layer, which is the red image. Okay. But we want to be able to see the three images composited kind of through each other, or added together. We're adding the red light, the green light, and the blue light together. So to do that, on these top two layers, we need to use this layer setting tool right here. And we're going to set the mode from normal to screen mode. All right. So now I'm seeing the blue, I'm seeing the green image through the blue image. And now I'm going to go to the green layer and set that to screen mode. Now I'm seeing through all three images are being added together. I can see the light from all three images, and I'm back to the original color of my three blocks. Now, there is a move. You can see that my camera kind of wasn't perfectly aligned on the three images, and this tool here is a move tool. And if I'm on the green layer, let me get that down there. On the green layer, if I'll be moving the green layer. If I move it out of the way, you can see blue plus red light gives you these kind of pinky magenta things. I add the green in, and you're back to seeing the original colors of the towers. So to finalize your image, you want to flatten the image. So you want to take the three layers and make them one. You're going to flatten the image. And then you can save that image under File, Save, and you can save it as a JPEG or a PNG image. And I'm going to save this as Towers RGB. Oops, B. Okay. So doing this activity before actually doing the three-color image with celestial objects can help kids understand how you can create an image that tells you the true color of something out there without having a color camera. Okay, but by just using red, green, and blue filters.
Mary, I got a question.
Yeah.
And
I assume screen mode changes opacity.
Which I don't think is true.
Yeah, that's actually not the case, and it's a little tricky. I have to say I'm not a pixeler expert. This feels like a question that we need Joe with us at some time to talk about some of the different features of Pixlr, which is similar to Photoshop. But the screen mode does not actually, if you try doing it by setting the opacity of the three images, I haven't been able to make a true color image that way. So, so I know you're trying to, Photoshop and GIMP terms. So you're familiar with some other photo processing, and
there is also an opacity.
There is an opacity tool right here, yeah, in Pixlr, and you can certainly experiment with it. But as you'll see in a minute, when we move from smartphone images to microobservatory telescope images, it's that screen mode that's going to help us composite the 3 layers into one RGB image. I didn't see the images flatten. Adrian, all that means is rather than having 3 separate images, the thing that I'm saving is a single image that looks like what you see on the screen. I'm not sure if that makes sense. So, so now you can see that I've only got a background instead of 3 layers, right? If I look at my layers tool, I've only got 1 image here, not 3. So flattening an image in the image processor means you're literally making 1 image out of the 3 separate images, flattening them into 1. Well, let's try it with the Orion Nebula and see if that helps us understand what's going on. So I'm going to actually go into the portal here, and I'm going to go to the JS9 tool. And I have some images of Orion that came out from actually week before last that came out quite well. It was a good clear night, and so I'm going to use those. And so they were on the 15th. And again, if you haven't noticed, these file names on your images actually tell you exactly when the image was taken. So I'm going to open Orion Nebula 160115. So it was taken in 2016, January 15th. And then these last 6 numbers, 05, 33, 22, are the exact time in universal time at Greenwich Mean Time, which is what astronomers use. I know some of us, a lot of people have been trying to jump on to the webinars either an hour early or an hour late because we've had some confusion about whether the webinars were in Eastern time or Central time or how to do this. So astronomers solve that problem by always using universal time, the time in Greenwich, England, as it were. So these images are labeled that way. Anyway, all right, let's get back to RGB. Here's my first Orion Nebula image, and it's taken, I'm not quite sure if it's taken through the red, green, or blue filter, but I can find that out if you'll recall, because under the image tool, there's a command called display fits header, and every image taken by the telescope includes with it a header that has all the information about how that picture was taken. So if I look at the fits header for this image, it tells me it's the Orion Nebula. Here's when it was taken. The exposure time was 60 seconds. These are coordinates, the altitude and azimuth of the telescope, but it tells me here, blue filter. So this is the blue image, okay? So now I know that. But I want to bring out all the details in this image, and if you remember, that involves bringing this high brightness limit down, okay, and using that log scaling tool for a dim image. So I go to log. Now it's starting to come out. When you first click on log, often the background sky will be too bright because it's a dim object too. And remember, log scaling kind of boosts all the dim values. So here's how you fix that. You move your cursor in the background, what should be dark sky, and look at the pixel value right down here. And as I move my cursor, you can see it's always around 288, 289. So if I select my low brightness limit and I type right in that box 289 and then hit enter, watch what happens to the Orion Nebula. Okay, so I've made everything valued 289 or lower appear black, and anything slightly above that gets all these levels of gray, so it really brings out the detail in this Orion Nebula image. This one was the blue one, so I'm going to color it blue, and I'm going to save this as a PNG, for uploading into Pixlr in just a minute. So Orion blue filter, right? Now I'm going to open the next Orion image from that night, that 15th. Here it is. And I think this is the green filter, but I'm just going to check. Let's see, display fits header. Yep, there it is. It is the one taken with the green filter. Again, I'm going to bring the high brightness limit down. Things start to come out here. I'm going to click log scaling. Starts to appear. I'm going to find out what the background sky is. It looks like it's right around 290, 292. So I'm going to set my low brightness limit at 292, 292. Enter. Ah, okay. And there's the green image, and I can tweak a little more with this high brightness and get a lot more out of that. I'll save that. This is the green. Save that as a ping. Whoops, wait a minute. Ah, stop it. Save as a ping. There we are. Orion green filter. All right, and finally, I'll open the blue one, and we'll do the same with it. Orion blue, green. This one is the red. All right. High brightness limit down. Log scaling. The background here is about 296. I'll type in 296. Enter. And there's a lot of information here in that red image. So that was red. Save that. Orion red filter. All right. Now we're ready to go to that Pixlr editor. I'm going to close up my towers image. I'm going to open my Orion RGB. So here's the red image. Remember, the next two you want to open as layers. So open images layer, the green on top of that. The next layer, open images layer, the blue. Okay. And so now we have the images on top of each other. If I, again, unclick the blue, you can see down to the green. If I unclick the green, you can see down to the red. But we can add them all together if we use this screen mode. So on the blue image, I'm going to click screen. So now I have the blue and the green together, but I want to see down to the red image. So on the green layer, I'm going to set that to this screen mode. Okay, so now I'm seeing down through all three images, green, blue, and red. But you notice the telescope wasn't pointed at exactly the same place. So I want to move these images. So if I click on the blue layer, and I click on my move tool up here in the upper left, right, I'm going to slide that around so it's right on top of that green stars. Now I need to move the red layer because it's down. I'll click on the red layer and I'm in the move tool and I'll slide that up. And now I have my 3-color image. I can also do, can I do this? I guess I should flatten it first. In each layer, there's some other things you can enhance these further. You can add text to the image in this is my Orion Nebula. I'm going to make that text, I don't know, green. Oh, that didn't work. Why not? I'll make it red. Green. There we go. Okay. So I can move that around. And I can tweak, adjust the brightness and things like that up here as well. So, all right. I'm going to save this. Actually, I guess I flatten it first. Flatten the image. So now I have one image, one layer, and I'm going to save that as Orion Red, Orion RGB. Okay. And now I'm going to go back to my educator portal, and on my wiki page, share your processed images. If those of you who haven't done this yet, there'll be a right now you'll see a tutorial on posting to your wiki page. Oh, I think there've been a page added since the last webinar, or when I didn't notice. Here are my images, Mary's images. So I click on that. I posted an image comparison between microobservatory and Hubble before, but I want to add my new Orion RGB, so I'm going to edit. And I want to add my Orion RGB after what I have on the page so far. So I'll click right there. I'll click on this image tool, insert image. And now I have to go find it on my desktop. Choose file. There it is, Orion RGB. I'll save as Orion RGB. Okay, there it is. I'm going to add an image description. Orion Nebula. Okay, and insert. There it is. And now if I want to save my edits to my wiki page, I click save. And there it is. So I have my new RGB image, and your mission, should you decide to accept it, is to try to do the same after you feel you've mastered false color imaging. Try and do a true color. I have a question in the chat box from someone who's used our old microobservatory image processing software. Is there a way to do advanced RGB with the dark subtracting on this version? Elena, there is not right now, but there will be. We are working with the software developer of JS9 to add image addition and image subtraction. For those of you who are wondering what we're talking about here, this is an advanced image processing RGB that gets you an even better image than the one you see here. There are tutorials for using the external microobservatory image software to do that. But right now, Elena, the JS9 does not offer the option to subtract a dark image from a filtered image, but it will.
I got an answer for the screen mode.
Ah, did you write to Joe?
No, I picked it up.
Oh, yeah, okay, yeah.
Although I will ask him as well.
So Erica has found something about the screen mode.
Basically, it's like projecting onto a screen, so you're building the light.
Oh, I love that.
Yeah.
I mean, yeah, okay. So Erica says Pixlr describes the screen mode as what happens if you project 3 images onto a screen. So you're adding the light together from the 3 images onto the screen. So yeah. Any questions about what we've done so far, or how the filters work, things like that? Giving a little wait time here. Okay, good. Well, let's see. Now that we've practiced a little bit of our own artistic sense and bringing out the 3-color images here, and I actually didn't do much processing other than just adding the 3 images together. I didn't do a lot of tweaking of the brightness of each color, red, green, and blue. The next step is often helping students create captions or helping them relate to their images. And so we wanted to show you an activity that we have also written up in the lesson plan materials, and it's called Astropoetry. So I'm gonna get us to that image here. Let's see, where are we? We did all the trees. Here we are. Okay. So right now I'm projecting on the screen not my own 3-color image of the Orion Nebula, but this one is from the Hubble Space Telescope. And in fact, it was created in exactly the same way that we just did. The Hubble Space Telescope can't see color either. In order to get the images, they take an exposure through a green filter, through a red filter, through a blue filter. The Hubble Space Telescope has lots of other filters that they use to really observe different segments of objects in space. But you can see that although it's much higher resolution than our microobservatory image, it really comes out in similar colors, because those are the colors that the Orion Nebula is glowing with. If you could, if you could get out there in space and have big eyes and be able to see it, it would be glowing kind of pinkish. The hydrogen gas that this cloud of dust is made of glows in pink. So we're going to do astropoetry, and here's how it works. I am going to get out my annotation tool, where I can create words on the screen. And you guys are going to help me. So this is the way the astropoetry activity works. I'm going to ask you guys to look at this beautiful image of the Orion Nebula and generate words that are either nouns, verbs, adjectives, or adverbs. And as you type those words into the chat box, I will use the annotation tool, because I thought you guys had the ability to write on an image as well, but apparently you don't. So type into the chat box, and I will add those words. I'll start. I don't see any oh, wait, a beautiful swirl. All right, beautiful. And I'm going to add them as separate words. Swirl. Okay, all right, you need to, single words here. Swan. Swan. It does look kind of like a swan. Pinpoint. Pinpoint. Okay, let's see. Pinpoint. Thank you. If you could read them to me, that helps. Breathtaking. What else?
Dynamic.
Ooh, dynamic. What else?
Flowing.
Glowing.
Flowing.
Flowing. Flowing. It's flowing and glowing. Flowing. Glowing.
Sistine Chapel.
Oh my. Sistine. Have I got that right? Here.
So they spelled it.
Sistine Chapel.
Majestic.
Majestic.
Explosion.
Explosion.
Powerful.
Powerful. I don't, I've got a couple of verbs. I think some more verbs would help.
Creation.
Creation.
Abstract.
Abstract. All right. Any others here?
Whirling. Diffuse.
Whirling and diffuse. Oh. Whirling. Whoops. Whirling. Diffuse.
Pop.
Pop. Pop.
Motion.
Motion. All right. These are awesome. Okay. Well, I'm going to stop us there. And if I were doing this with a group of students in a class, or I first learned of this activity from a museum colleague at the Museum of Science, and we used to do it around the statue of the dinosaur, but it was a way to get students to start to generate descriptive words, to really observe something closely, and to help them be descriptive and interpretive as they look at an object. So if I were doing this in the classroom, I would give every group of kids some index cards, and they'd write one word per index card. So then you have this stack of index cards with all these words on them. And the next part of the activity is to arrange those words into lines to create your astropoem. So if anyone wants to kind of look at these different words and create a first line of 2 or 3 or 4 words of the poem, I will move them into place. So does anybody see a first line they want to begin with? You can type it in the chat box. Oh, come on. We're all... I can start here, maybe. Oh, wait, majestic, beautiful swan. Excellent. Majestic, beautiful swan. All right.
Powerful explosion whirling.
Ooh, I like it. Powerful explosion whirling. Whirling. Right, what's next? Dynamic, Sistine Chapel. Dynamic. Sistine Chapel. Breathtaking, flowing motion. Oh my, creation of motion. Oh, creation of motion. This is where you get to cheat a little bit too. So we have breathtaking creation. Diffuse.
Like it.
I like that. Diffuse. It kind of seems like a good ending line, doesn't it? Diffuse. Whoops. Let's get swirl out of here. Diffuse. Abstract. Pop. Majestic, beautiful swan. Powerful explosion. Whirling. Dynamic Sistine Chapel. Breathtaking flowing motion. Creation of motion. Diffuse. Abstract. Pop. I feel like a beatnik. This is great. So, you guys have, I sound like one. Yeah, great. Anyway, this activity I always find is a lot of fun and a great way to get kids to think about interpreting their images. Of course, you can also have kids do research on the object that they've taken a picture of. So they can do research on the Orion Nebula and what it is and why it appears the way it does. But I think sometimes the poetry is a nice way to expand upon that. All right, I'm going to take a screenshot of this poem before I move on here. Okay, and I'm going to clear the drawing. Let's see, let's go. Oops, there we go. So just in terms of creating capstone projects out of their images and poems and interpretations, here are some young kids from Adrian, who's on the line, one of her centers, who created sculptures to go with their images, and they compared their own images to, these are actually Hubble telescope images, so they had their own images, Hubble telescope images, and then sculptures trying to interpret their 2D images in 3D. And here's another group that created these kind of poster exhibit displays. Here's one called Galaxies Galore, and I've excerpted a couple images and captions from this display. And you can see the kinds of things that students put together as a project, both researching about, in this case, about a galaxy, and also interpreting it from a personal view as well. I love this caption that Freddie here has done. 1 inch of flying stars seems like an image of a flying saucer. And he's talking about this irregular galaxy here. So anyway, any questions to this point? Comments? Right. Okay. Well, we kind of wanted you to get a feel for some of the other things you can do. Your mission now is to continue to check out the educator portal and the activity portal, and to go through and complete the items in the training workshop checklist. So if you haven't posted your own images yet, do that either in one of the discussion forums or on your own wiki page. Please contribute to the discussion threads, in particular about how you think you might implement some of these activities, because I think we'll all have a chance to learn from each other. And the kind of completion of your assignments for the online training workshop is to create your capstone wiki page, which there's prompts on that page about reflecting on what you've learned in exploring the portal and how you think you might implement. So that's kind of creating your capstone. Your students will have their own wiki pages. They can create capstones.
We actually have a question on that.
Oh, there is a question.
Yeah, it's a multi-part. Who thinks of the capstone project, and is it the child's idea, the teacher's assignment?
Ah, great question. So this is really up to you. So remember that those essential elements of the Youth Astronet program are using the telescopes, using the image processing tools, and using them to pursue some kind of investigation or capstone project that you create display or report or web page or video, and to some degree, that's a decision that you as an educator can decide, because you know the resources you have in your computer lab or on, you know, whether you have movie making or whether you have the resources to create posters on poster board and things like that. But we also think it's really important to give students some choice in that. So one of the things we really want to promote is having students have choice and voice in deciding on their capstone projects. And of course, their accounts on the YouthAstroNet portal are their own, so they can post what they want to. Yes, so exactly, Pam. It'll be great to see. That's one of the reasons we want you guys to post your own capstone wikis, so you can look at each other's and get ideas. There will be a lot of ideas that we'll learn from each other. And I do want to point out that this second live webinar is not the end of our conversation, but the beginning of our conversation over the next several months as you implement and as we guide you, because we will always be monitoring the online discussion groups, helping you. We will actually probably next week have another webinar that's optional, but where we'll show some other tools and things, and of course we'll post that webinar on the portal as well. Wanted to point out that student accounts will start being available kind of starting in mid-February. We have to create all the materials for you to use to create student usernames and passwords, and materials for getting parental consent for the students to have an account and to take the pre-surveys that they'll take once they have an account on the website.
That'll all be on the portal.
Yeah, that will all be on the portal. Yes, right. You deny, right. We haven't sent the permission slips out yet. We will, all the materials for that will be coming out in the next couple of weeks. Yeah. Other questions, comments? Are there questions? Did I?
So, yes, you will be able to continue with YouthAstroNet.
Oh.
Will I be able to continue with YouthAstroNet next year?
Yes. Will I be able to? Okay, I'm not seeing that question.
Oh, sorry, that was just me. Sorry.
You guys are now part of the YouthAstroNet group, and you can remain a YouthAstroNet educator for as long as we keep the project going. We want you to continue to use it, and we want to learn from educators who have experience using it several times. We do have some educators on the webinar right now who have used microobservatory before, and so they have experience in helping kids use the telescopes and do some image processing, and so they can help some of their educator wikis will have ideas for those of you who are newcomers, and we hope that you newcomers will become veterans who will then share your information with newcomers in the future. All right. Well, yes, educators and students will receive a certificate of completion. In fact, I haven't quite finished the certificate of completion for you guys. We'll give you information so we'll have a certificate of completion for educators, and there will be one that students can print out as well. And there are also badges within the student portal that they earn as they complete numbers of activities. Yeah, the Pixlr. So the Pixlr will create links inside the Youth Astronet portal directly to Pixlr. It's at pixlr.com, but we'll create links to it. It'll just open as another browser window. You don't need an account. It's free. It does allow you to log in and create an account, but you don't need one at all. When I just showed you this, I do not have a Pixlr account. Okay. How long will each session last? And again, that's another choice, different formats. Some of the I know that some of the educators we've worked with in the past have had their micro observatory program. Actually, some of you, in looking at the we've called a program Youth Capture the Colorful Cosmos, which some of you will see educators referring to in the Introduce Yourself portal. And that's a kind of a pilot program for this Youth Astronet program. In the Youth Capture the Colorful Cosmos, or YCCC program, educators have used different formats. They've done 3 Saturday workshops in a row of 3 or 4 hours as their program. Other educators have offered a once a week or twice a week after school from 3 to 4:30 or something like that for 5 weeks in a row or 6 weeks in a row. Other people have used it continuously as an after school club over a whole semester. So again, it is highly adaptable to your individual context. We'll keep this conversation going on the portal. I want to thank you all for your time joining us on this webinar. It's been great, and I'm gonna actually stop the